Now, our cosmic voyage enters another dimension. The dimension of time, where knowledge is much less certain. Studying traces of quarks from these collisions, physicists try to learn what our universe was like when it began after the explosion known as the Big Bang. One of them outlines the theory.
Welcome to Fermilab. Today, astronomers see the universe expanding. Imagine running the expansion backwards. Billions of years ago, everything must have been packed together at enormous density. It seems incredible, but we think that the matter making up everything we see in the universe today, everything, the buildings, trees, people, planets, stars out to the most distant galaxies, was once crammed together into a volume smaller than this. And then,
space itself exploded in a burst of radiant energy. In those first dazzling moments, the newborn universe began to expand and cool. Quarks combined into protons and neutrons, which later attracted electrons to form atoms, and the vast fog lifted. For hundreds of millions of years, the force of gravity slowly drew matter together into a gigantic web, the architecture of the cosmos. Two billion years passed. Clouds of gas and dust condensed like giant water drops along the cosmic strands and formed galaxies. Where the great ridges of matter crossed, galaxies came together in clusters. Some galaxies evolved into gigantic disks and spirals of stars, gas, and dust. Neighboring galaxies, trapped by their mutual gravity, draw together in a fantastic collision. In real time, it would last 1 billion years. The force of gravity strips long tails of gas and stars from the huge new galaxy. And yet stars almost never collide. So vast are the distances between them. Perhaps 10 billion years pass, and we encounter our own galaxy, the Milky Way. In it, stars have formed, and some have died. Stars are nuclear furnaces. They shine until they use up their fuel. Massive stars end explosively. These exploding stars, or supernovas, send out the elements of life: the oxygen we breathe, the carbon in our muscles, the iron in our blood. Now a cloud of cosmic gas sprinkled with these elements comes together in the grip of gravity. A new star, our sun, ignites. Around it, planets form. In their infancy, over 4 billion years ago, our Earth and Moon were bombarded constantly by cosmic dust, asteroids, and comets. With violent impacts, volcanic gases, acid rain, and potent ultraviolet radiation from the sun, the young Earth was a very hostile world. And yet, the basic ingredients of life were already here. Water, carbon, and energy. Scientists speculate that molecules sheltered by the sea somehow combined, multiplied, and gave rise to life. For millions of years, Earth's only organisms were tiny bacteria. Some, called blue-green bacteria, slowly released tiny bubbles of oxygen and profoundly changed the atmosphere. Above the clouds, some of this oxygen formed a thin layer of ozone, blocking most of the sun's ultraviolet rays. In this changed environment, new organisms flourished in the Earth's waters. Colonies of green algae produced more oxygen. Then organisms evolved an astonishing variety of forms. Some with shells or skeletons for protection and support. Others evolved complex life cycles, like this tiny crustacean. And the shallow waters of the seas filled with a teeming diversity of life forms. Life's next challenge was to colonize the harsh, dry land. Bacteria were first, followed by algae, plants, and animals. Vertebrates appeared on land, feeding on both plants and animals, and gave rise to larger and larger life forms. Some of them conquered the realm of the air, and others the great open plains. Our cosmic voyage from the Big Bang to the appearance of humans took about 15 billion years. From the beginning, we were explorers, inventors, and technicians. And in a few thousand years, just an instant in cosmic time, curiosity and technology would take us back toward the stars.